Our guest is an assistant professor at York University, Canadian Research Chair in Metal-Free Materials, that makes more sense, metal-free materials for Catalysis, and his research is in developing greener and more sustainable chemistry by eliminating the use for expensive and transition metals. Please welcome to stage, you've already seen him, Dr. Chris Caputo! Grab the mic so that we can all hear you well. So,
thanks for the kind intro.
Yeah. Well, I mean, you earned it. Literally, you earned all these things through either school or work. But let's start off. Tell us a bit more about your work. What is some of the stuff you've been working on?
Well, the stuff that I've been working on. Let me ask you a question.
Sure.
Do you have any tattoos?
I don't.
Do you want one?
I have an issue with committal. Perhaps your tattoos can address this concern.
Are you offering a tattoo right now on stage?
I got a tattoo gun in my bag. Yeah.
Oh boy! I have friends who have done that on stage. I will not.
That's fair.
Yeah.
No, so our research, you kind of stole the thunder with the introduction.
Well, I did read an article on this, so I know who I'm dealing with.
No, we have an awesome team of scientists who are working on a lot of really cool chemistry around more sustainable processes, and that kind of falls under two buckets.
Okay.
One could be removing transition metals and precious metals. When you make molecules, you need usually a precious metal to make bonds, and if you want to make a pharmaceutical, you're going to use palladium or platinum or something that is super expensive and rare. So we work on ways of doing that with more earth-abundant elements.
So are you saying there's a bunch of metal and stuff we're unaware of, like stuff that we just do every day that we don't realize there's metal in? Because it just needs something to bond with?
The process to make, so like your diabetes drug, let's say, or your chemotherapy rate or something.
I take antihistamines.
Your antihistamines, maybe not, but
okay.
maybe.
Felt like you had an exhaustive list. I figured I'd throw that out there.
To make those molecules, you need different chemical reactions that are facilitated by these precious metals. And like platinum, for example, super useful, or palladium, super useful in chemistry, but the amount that you mine each year and we refine as a species is like the size of this room. It's so rare.
It's a big-ish room, but it's not big in terms of the world's usage.
Yeah, it's nuts. So we try to make alternatives. We try to make molecules behave like those, but they're based off of things that are more common in the crust.
Okay, and was that in your introduction?
We
talked about
tattoos.
Okay, great. We'll circle back to the tattoos. I do want to go into this. So we were talking in your introduction about catalysis, or catalyst, I assume is
you can go hand in hand.
Yeah, same word, right?
Close enough.
They're not the same word?
A catalyst is an item, and a catalysis is a process.
Okay, but what I learned in high school, and so that was many years ago, so I don't know. Catalyst is a thing that makes a process work better or faster, but not necessarily part of the process itself.
Yeah, you're right. It facilitates the process, yeah.
So you're saying we're using all these metals in that way, where they are needed to make the thing move faster or cleaner, but they don't end up in the end product? Are we shoving a bunch of extra metals in ourselves? We don't know. And my part sideboard.
We do have to test that. No, you do have to test that it's all there. No, they're filtered out. They're cleaned up before you eat it.
I mean, I was hoping I wasn't full of metals. And I mean, maybe I could lose a lot of weight if we just cut out all those metals.
It might not be coming from your drugs that you're ingesting, but maybe from the air you're breathing.
Great. Metals in me anyway.
We have experts in the room that can tell us about that.
Okay, we'll check on them later. All right, we'll circle back to the tattoos. So most tattoos I'm aware of do revolve putting metal in you, right? That's the basic normal tattoo is needle with a little bit of metal, and then your skin can't break it down, so it just kind of sits in your skin, and then you get a pretty picture on yourself.
Yeah, it's fascinating, real tattoos. Like, there's so much chemistry behind it. Yeah, you're right. You usually have an inorganic, like a metal pigment that is completely insoluble, and when you have the tattoo gun or the needle that's injecting the ink in your skin, your body is like, whoa, I'm being attacked, and it triggers an immune response. And so you rapidly develop scar tissue, the macrophages come in and trap all the ink particles there, and then your body can't break it down.
Oh, okay, so macrophages and attacking the metals, and then it doesn't work? Like tattoos are a failure of our immune system, essentially?
I've never never thought of it that way.
Well, you're saying the body goes metal bad. I show up, but then they don't get rid of it.
It's a defeat. We defeated the immune system.
Okay.
I think that's what it more is.
That doesn't sound great.
No,
if you're supposed to be selling tattoos, I guess you're not selling the old ones, but
yeah,
you're not being like your body fails to defeat it. Is not necessarily the sale.
Well, the particles of ink are so large. Your body recognizes that they're a foreign object, but they can't do anything about it. So it's just like a truce. You were talking about politics earlier.
Sure.
The news. It's just a truce.
Okay, a truce. So we have metal inside of us. But
it's very colorful and it doesn't fade. And
they're real cool and pretty.
Forever.
Yeah, and they are forever. I guess again metal in our bodies? We normally think that's bad, especially if they're heavy metals. But are traditional tattooed metals unhealthy, or is that not the problem you're fixing?
That's an interesting question. I think it's because your body can't do anything about it. I think the toxicity risk is pretty low.
Okay.
Like it's just sitting there in your skin.
It's weighing us down a little, but it's not causing us any grief.
Now, if you were to like hit it with a laser and you want to remove the tattoo, that's when things get a little. I don't know what the word I'm looking for is. A little spicy.
Okay, so we're getting everyone who has tattoos already, you're good. But now if you don't like that tattoo, what is the problem? It sounds like there's a problem.
Yeah, when you hit it with a laser, what it does is it breaks the particles apart.
Okay.
So now they're smaller and your body can start to digest them. And what happens is your immune system kicks in, it takes the dyes to your lymph nodes, all the metals are processed in the body, and then it starts to actually get into your system. There doesn't seem studies.
So removing the metal doesn't work.
Studies have seemed to show that there's not a crazy amount of risk.
Okay.
With this, but you're gonna get more metals into your system.
Which I still think metals in system bad. I think we're on the same page.
Unless it's iron.
Yes. Okay. You found an exception for me. All right, so you're working on something different though. So there's we're all a little bit scared of metal, whether we're safe with it sitting in us, or whether it's getting lasered and it's not getting where we want it to be. But you have an alternative entirely that's not metal at all anymore. What are you using instead?
So this falls under that umbrella of sustainable chemistry. So one arm is the catalysis part. One arm is using kind of renewable resources, and that includes like fruit extracts and stuff. And we have these really nice fruit extracts that change the color of your skin.
Is this one right here?
Yes. Yeah. This is.
Please present it well in the light. Up in the right. So this, I assume, legit tattoo the whole time.
I wish. I'm too chicken to
commitment issues. Both of us. Commitment. Yeah, it's hard.
It's more the needle, but.
Okay. Oh, are you not even? I still assumed a needle was involved.
It's totally painless.
Okay.
Just topical application. So what we do is we take these like fruit extracts. We know they change the color of your skin when there's a chemical reaction with the outer layers of your skin. When your skin sheds, it goes away. So it only lasts 2 to 3 weeks.
That's not nothing. 2 to 3 weeks is like a good amount of time. Like I'm thinking how much everyone here pretty much has a stamp on their hand right now, and that's gonna last. Well, you didn't pay. You snuck in, and that's probably gonna last till at most tomorrow if you don't wash enough. Wash more. Get rid of it tonight. Wash your hands. Still pandemic.
But this changes the color of your skin. This is my skin. I can shower, scrub, do whatever I want. It won't go away.
So there's no risk of removal early other than skinning
unfortunately, yes.
Which then you've got separate issues. No longer worried about your tattoo once someone's taking your skin off.
Yeah, when you have like high school sleepovers with your buddies.
I don't remember skinning, but okay, continue the story.
What types of parties were you going to?
They tried to make me pee once, but that's as far as it got.
You know when you fall asleep first and your face gets written on with a Sharpie?
Sure. Yes. Okay.
This could turn out really bad with these markers we have.
Right. Yeah. No, it's going to be dirty words or dicks on your face for sure. Well, how easy are these to how easy are these to apply?
Super easy.
So
you can print whatever design you can order. It goes right to your mailbox, whatever design you want.
Okay.
Or you can buy a marker.
Is it you essentially? Yeah. Is it more that you're printing it out, or is it more that you're using a marker, or does either work?
They have options for both.
Okay.
Yeah. So
you could just end up writing on your arm, doodling, and then realizing, whoops, the tattoo that's there for a while.
Yeah.
If you don't know, if you grab the wrong pen from the drawer.
Yep. Yeah, I got to keep it away from my kids.
Yeah. Oh boy. Don't trust children. Oh jeez.
But it's fun. It's like the chemistry of this is very underdeveloped. So we have an awesome team. 3 of them are sitting over here.
Yes.
Woo! Who are changing these molecules. They're changing the color, and we're working on like getting those out there.
So what? So you meant it was a fruit extract. What fruit are we talking?
One you probably never heard of.
I want to hear about it.
The Genepa americana plant from like Colombia, Panama, like Central America.
Okay. Someone's heard about it.
Perfect.
Side note: does it taste good?
I doubt it.
Okay.
I've never tried it.
Just I want to know
Probably
about more
turn your
fruits.
tongue blue.
I mean, that would be a problem, but also kind of cool. I guess it's stuck there for 2 to 3 weeks. Unless, does my tongue not shed skin?
I don't know. Any biologists in the room? Doctors?
Tongue shed skin? No, we don't know. We'll have
I
to
assume it does. Let's assume.
do some tests. Do some
Yeah.
tests. Well, yeah. Okay. So if it's a fruit extract, does the fruit do this in nature? Is there any changes you have to do to the fruit extract before it starts having this property?
There's one special molecule in it that
Okay.
that we can extract out of there or buy. Someone extracts it out for us.
Okay.
So
the fruit in the
play with
you-
that molecule.
You can't just grab the fruit juice, throw it on your skin. That wouldn't
You
be enough.
could, but like the shelf, like it's not a good product.
Okay.
Like, if you want to develop a product, it's not
All
good
right.
for that.
So that's pretty interesting.
It's all chemistry.
It's all
Tattoos are
chemistry.
all chemistry.
Yeah, I mean, again, they're mostly metal, and you're doing non-metal stuff. So,
Yeah, but we can make some really nice colors without metals.
yeah, it's true. Are in traditional tattoo as well? There's non-metal ones.
There are. They're not as. They're harder to make because the body can break those down because they're
Okay.
like organic molecules, so they can start to go away and fade over time, and they look worse.
Okay. Tell us a bit more about the catalysis part. So we got the tattoos. We've talked about the tattoos. Oh,
That part's not as funny.
okay. I'll make it funny. You make it interesting.
Okay.
Tell us a bit more about some of the things that I guess we that you're taking metals out of that we aren't aware of. What are some of the things that you are able to make more sustainable?
So one like crux of chemistry to make new molecules is you want to form carbon-carbon bonds, and that's really hard to do.
Is that the strongest carbon-carbon best pairing?
It's not the strongest bond, but it's the most versatile. So
Okay.
you can make the most kind of variety of molecules. It's fun being a chemist because it's almost like being a Lego master or something. You're just building things up that you can't really see.
Yeah, it's very tiny Legos. The
it's
smallest Legos in the world.
It's better than physics because physics, I think, just looks for answers to questions. We can build stuff here.
What fighting words?
A shot across the bow.
and
I
and
didn't know
also,
there was
you just
physicists in the
find
audience.
answers to life's biggest questions. Fuck you.
Yeah, we get to build stuff.
Okay, you can build stuff. That is cool.
So constructing molecules is hard to do. There's a lot of really good ways of doing it, but a lot of them involve metals. So can we find, like what we seek to do is find alternatives to that? Can we do the same transformations, but eliminate the platinum, the palladium, and all that jazz?
Okay. I'm actually going to talk to you a more general chemistry question that always gets in my brain. So you talk about like the Lego building, and we've seen those like chemistry sets where you snap things together or you stick things together with paws. And that always seems, well, but it's real tiny. What's the actual process at the human scale when you're actually going into your lab? It's not snapping individual carbon into oxygen into hydrogen, right? What are you actually doing when you're trying to build something so specific, like organic chemistry, giant Legos? What do you actually do to make something specific? What's the process?
You know, it's probably been 10 years since I've done any chemistry myself. Does some people in the lab want to answer this question?
Whoa! I did not think I'd stump you with, how do you even do that?
Yeah. No, it's so over the probably 150 years of organic chemistry and chemists discovering ways of changing molecules, there's a library, an encyclopedia of, let's say you want to go from A to B, this is how you do it.
Okay.
And so we're starting with whatever you can buy. Like you buy a bunch of starting materials, and there's kind of it's like
Baking soda, vinegar.
yeah, we can do that.
Cool.
Actually, we have both in our lab. Yeah.
You mean kitchen?
What do you do? Do you like
Same
weekly, every other day?
How many volcanoes?
Every other day.
Lots of volcanoes. Lots of
Yeah.
volcanoes.
Like so you almost have a cookbook of how you can make molecules. Just like if you're it's like cooking.
Okay. Well, okay. So that makes sense up to a point, but then you're talking about making stuff that doesn't already exist. So you got to add new pages to the cookbook.
Yes. That's the fun part.
It's fun, but is it also as messy as cooking off cookbook is?
Oh yeah, I'd say like 95% of the attempt, maybe 90% of the attempts don't work.
Right.
Right.
And when I burn a souffle, I burn a souffle. Have you ever accidentally made a bomb?
Oh God.
How often do you make a bomb by accident? I think of chemistry, I think of explosions. How often have you made a bomb?
Me personally,
Yeah.
have fire is a common element.
Okay.
There's at least 4 occasions I can remember of things exploding.
Straight up exploding.
Exploding.
Not expected, just like, let's see what happens when this goes with this, and boom.
Well, I should have known.
Okay.
Sometimes, so like when you do chemistry, a lot of times you make new molecules, it releases heat. It's just because it's favorable, so you release heat. And sometimes if your scale is too large or you don't have the temperature controlled well enough, you can run away, like the heat runs away and you boil everything over, or your vessel explodes, or
Yeah, I've heard about that.
Or
That's called a
things catch
bomb.
fire.
You're using extra words to say bomb.
Yeah, but I'm not going to be able to cross the border anymore.
We are recording this, but I won't send it to the TSA. So yeah, I always think of explosion. Okay, so let's go a little. We've done your specific stuff. Let's get a little more broad on chemistry again. There's lots of elements. We got a whole table of them. What are some of the things that make them act particularly different? Like, we get told the only difference between them is the number of protons. This one's got one more. How do they act so goddamn different just on one little number being different?
Is there a chance we can pull the periodic table back up?
Dave, can we get the table back up?
Maybe.
Maybe.
Maybe not. Maybe
Okay.
if we can, great. If not, so
Keep it broad.
you see the periodic table has all those different sections, and there's all the different rows and different columns, and so it's not just difference of protons, but they have different electrons, they have different neutrons. So that gives them all different properties. So as you move your way across the periodic table, there's certain patterns you can follow, and you go your way down the periodic table, there's certain patterns you can follow. So if you kind of go a straight shot down, a lot of them have similar properties. They're just, oh, that's really nice and bright.
It's real bright.
A lot of them have similar properties, so you can expect complementary chemistry.
So I know, for example, everything in the first column, if you add water to it, hey, we got it.
over here.
Everything there, if you add water, there we go, bigger.
If you add water to these,
They all catch fire
they'll
and
catch
explode.
fire, they'll
Yep.
make hydrogen and catch fire, because these. Oh, my boss in the audience, I gotta be careful. These want to lose electrons.
Sure.
And these on that side want to gain electrons. So it's just a matter, like a lot of chemistry is just what wants that electron.
And these guys want for nothing. They are
You
the.
would think
Oh.
that. Actually, I had thought about this.
I
in
heard they
advance
were
of the
noble.
show.
This is again. This is going back to high school chemistry. I thought these guys want for nothing. They are full up. They don't want to do things. Can you make them do things?
Most of the time, that's correct. But one of my favorite compounds, and one I use so much as a graduate student, is something called xenon difluoride. So that's 1 xenon atom and 2 fluorine atoms. That shouldn't exist.
Okay.
There's a lot. It exists, but based on kind of like the high school first year education, it shouldn't, because noble gases don't want to react.
Yeah.
But fluorine is so reactive; it wants electrons so badly. If you take a mixture of xenon gas and fluorine gas, they'll just look at each other. But you add like an electric spark, or you have like a little bit of heat, suddenly those two gases will precipitate a solid from the gas phase. And xenon difluoride, as you would expect, is super reactive and will kill you instantly if you like come in contact with it.
Not technically a bomb.
just lethal.
Just lethal.
Um,
So what? It just wants to not be xenon fluoride anymore.
it'll give up fluorine. Yeah.
Fluorine.
Yeah. So it's a really good. If you want to make organic molecules with fluorine in it,
Okay.
it's a really good reagent to use because it's going to give up the fluorines.
That's how we do the Legos then. Get
Yeah.
something that doesn't want to exist, something that is an abomination against nature,
Yep.
and then it'll give up whatever's extra.
Yeah.
Okay.
You got it.
I
You're a
figured it out.
chemist.
I'm a chemist, guys. I use deadly things. Anything else? Well, we got the table up here. Anything else worth discussing on the table?
So these are those precious metals that I was talking about. Like
Yeah,
palladium,
palladium.
platinum, iridium, rhodium, ruthenium. There's actually been some like studies by banks that have like looked at the feasibility of mining asteroids for these because they're so rare and expensive on Earth. So like, why can't we do that chemistry with things in the top right? It's so much more earth abundant.
Yeah.
But it's not as fun, I guess, as launching a rocket and
And-
mining an asteroid.
And check me if I'm right on this. So the stuff down here basically needs like supernovas to exist, right?
I think so. Yeah. Okay. Yeah.
Hey.
Confirmation.
we got an assist from the audience. Whereas these ones only require a star. We got lots of those.
Oh yeah. Yeah. Maybe
So-
we can even squeeze our hands hard enough and make some of them.
Right. Okay. So we can we make elements just by crushing stuff hard enough?
You can make elements by breaking things apart, like nuclear fission.
Okay.
I don't know if we've made elements on Earth with nuclear fusion yet. That's a question beyond my
Okay.
expertise.
Okay. Sorry, I'm going off.
Ask the audience. Anyone know?
Going to the
No.
audience a lot. I'm
Come to
sorry,
the
man.
next no show for
There's-
nuclear
I think-
fusion.
I think
There's
if you
three-
go to the
there's three
audience one more time,
professors
we
over
got to
there.
take away the doctorate. I don't know. All right. I got two last ones here. So one, just what is new and exciting in chemistry in general? I assume you're keeping up on some of the journals. What is something that's new and exciting in chemistry that we might not know because we're not as plugged into chemistry specifically?
New and exciting in chemistry.
Just anything recently. And recent can be real broad.
It's hard to say like what's new and exciting because it's completely like it's a continuously evolving field. This
The
is a
latest
stumper.
thing that like
This
you
is
read in the news and went and you wanted to share with someone, they're like, I'm not a chemist, I don't care.
Honestly, you kind of, when you were telling the news earlier about reducing sulfur emissions in
Sure.
fuel, that actually is like a oops, we were making climate change worse because
Yeah.
of this.
We can go deeper on that if you like.
That's for another guest.
Okay.
Two guests sitting at the table over there. No, so like I think the next, I think there's too much going on. It's like, and also, but the thing is, as a professor and a researcher, sometimes you get weeded, like kind of pigeonholed into your area.
Sure.
So it's really hard to say like what's the latest and greatest thing in chemistry.
You can be more specific. I don't care. I just want to
Honestly,
hear
all
a
the
cool
battery technology that's been developed, like batteries are all chemistry.
thing. All right.
Um,
And most of those we say lithium, which looks pretty high up on the table.
Yep.
But are we running out of that too?
I don't think so.
Okay.
I think there's quite a bit of it in the world.
Are we running out of the ions?
I don't think so either. Like I
Okay.
think batteries are here for a long time, and you can recycle them.
Oh, okay.
Right? So like you take your battery out of your phone, and you can.
They won't let me anymore. The way they made my
I know
phone.
Apple. Yeah. Well.
I'm fairly upset about it because it freezes up and I can't turn
You
it
can
off
do with
until
a
it
hammer
dies.
hard enough, maybe.
It's a problem. But
But in theory, like batteries could be recycled indefinitely.
okay.
In theory.
Okay, so let's talk about that chemistry a bit because that's definitely one that's in all of our lives.
Yep.
So we know that you can put energy into it and the chemistry changes, and then when we use the energy, the chemistry changes back the other way, right? Is that how batteries are?
Yeah. Yeah.
Okay.
Yeah.
Is there any inefficiency in that? Is there anything that's lost when we're doing a battery that just like kind of leaks out?
There's never going to be like 100%. Like you put 100 electrons in, you're going to get 100 electrons stored, you're going to get 100 electrons out. There's always going to be loss, like heat. There's like kind of, you're going to get thermal loss. You're going to get physical loss. Like you're never.
Sorry, is
gonna get
energy actually
100%.
this number of electrons in and a lot of number of electrons out? I thought it was more about moving them.
Engineers, I think. Yeah,
I lost
more or
my
less,
electrons.
more or less.
Okay,
Yeah,
basically though.
more or
yeah.
less. So like you see your phone battery, it's Like I got a phone a year ago, and now Apple's telling me my battery is at 88% health. I was like, what the heck is going on?
It's not as good anymore. Is there chemistry in that process that could help us understand why our batteries suck over time?
It sucks kind of because of the chemistry, because of the when the electrons go in, the electrons go out. Sometimes the structure changes a little bit, and if you get some deformations or it doesn't go back perfectly, you're gonna lose kind of a little bit of charge here and there, and then it just kind of snowballs over time.
So it's kind of like when you first start with it, it's like a neat pile and it's moving from one pile to another. But then later on, it's kind of like someone's getting hectic and they're just kind of making like unsafe piles that don't pile up as well. Like the papers are all out of skew and about to fall over, and they don't not as neat.
I think that's a pretty good analogy.
Okay,
that's good. Yeah.
Hey guys, I'm good at analogies. Yeah. It's my job. So you talked a lot about.
Oh, the most exciting thing is tattoos. Like
tattoos. The thing you're personally invested in, of course. How silly of me. You talked about sustainability. Is there anything you could tell us more generally about? We hear about forever chemicals, and we hear a lot about how chemicals are bad. They're everywhere. They're getting inside of us. That ain't good. Can you tell us more about that, or something we might not know about? Yeah. Chemicals just getting out in the environment.
You're going to take away my PhD because there's actually an expert in the audience who's much better
than
me.
Again, other than them, they'll correct you later. But the rest of us won't. Yeah, they can heckle if you're a little off.
When I'm wrong, just heckle me.
Get us as better. You just have to be better than everyone other than them.
There should be more heckling in science.
Fair, but they're in charge if I get promoted or not.
Oh, okay. Sorry, it's your boss.
Yeah. No. So. Wait, he gets a tattoo or I get a tattoo?
Boy. I did not agree to that, but okay.
So yeah, like forever chemicals, these fluorinated chemicals. So you talked about carbon-carbon bonds earlier and how strong they are and how they're the backbone of everything. Carbon-fluorine bonds are the strongest bond that carbon can form with another element. And there's nothing biologically that can break them down. So there's...
What would it take?
That was my PhD.
Great! So you got the answer. What would it take?
It requires exceptionally strong acids and highly reactive reducing conditions, and it doesn't work that well.
So we can't just spread acid into the ocean and hope that'll fix that. Feel like that's another problem. Feels like that would also...
As humans, as a species, we tend to muck around a little too much, I think. No.
That's fair.
But so these forever chemicals, yes, they're around forever because they'll take millions of years for natural processes to degrade them. I think there's only 4 naturally occurring fluorocarbons that actually exist. So that's super rare compared to what we make
do
in the lab.
Yeah.
But it's things like, do you like your non-stick pans?
I do. I hate cleaning, and it makes it easier.
So it's these trade-offs, these environmental trade-offs that we make every time we make a pan. No.
Are my eggs killing the world?
But the beauty, no, there's worse things.
Okay. It's not quite a no, but
the cool part and the exciting part about science is, we've made some oopsie moments in the past, but we have the opportunity to fix them.
Okay.
And we can do research to learn how they degrade naturally. Can we find ways of making them degrade faster? Can we mitigate the issues over time? They're challenges that we can solve. They might be in our bodies, but also the nice thing with fluorocarbons or forever chemicals is they're inert. So are they going to do anything to you? I don't know. I don't know what's worse.
I really wish you did know.
Your tattoo or some fluorocarbons. I don't know.
I wish you gave me when it was specifically there's stuff in your body. Will it hurt you? I really wish it was I do know and it's no. But I guess I don't know for sure is better than is cancer.
I think there's lots of things that will hurt you worse.
Okay. Yeah, a lot of bullies hurt me worse, but I still want to know if this stuff in my body is bad.
I don't know. How was that answer? Was that accurate?
Is he fired? Okay, not fired.
Yeah.
I think on probation, but you're not fired. Okay.
Tenure?
Tenure?
I'm tenured.
No.
It's okay.
Oh, okay, great. Is there anything I haven't asked you that you want to inform these good people about?
You asked me a lot of really great questions. That was a really fun interview. No, I think that the chemistry is like I talk to so many people who say, "Oh, I hate chemistry. I didn't get it in high school. My teacher sucked, and therefore I hate it." But I want to like talk to them and be like, "But chemistry is everywhere. It's like it's responsible for all our biological processes. It's all chemistry, right? Like everything we make is chemistry. The drugs we take, the solutions for future energy crises, pollution, new medicines, everything revolves around chemistry." I tried to dig out a shirt, and you wouldn't want me to wear it because I used to wear it in undergrad for every chemistry exam. So you can imagine what it smells like.
Mm-hmm. You can wash them. I believe detergent is chemistry.
I think it is. Yes.
So is the smell.
I think that's biological.
But the shirt says everything is carbon and everything is chemistry. So if you don't like chemistry, come talk to a chemist. We'll maybe help you like it a little bit more.
My high school chemistry teacher blew some stuff up in front of me, and that won me over. So.
Then you should come see my lab sometime.
We will cut this for the TSA. That version won't get on the air. But thank you so much for joining us, Chris Caputo, everyone. Dr. Chris Caputo.